Okay, product of powers rule. And we're going to have one for division and also one for when we divide a power by a power. But this is a big one. And we're going to write it in words, then with numbers, and then with a symbol. So the product of powers rule says this. If you multiply powers with the same base, comma, simply add the exponents. Okay. So let's see what this means. Here's an example with numbers. Okay. So here's an example with numbers. And let's say I have 9 to the 5th power. I multiply it with 9 to the 8th power. First thing we got to check, do we have the same base?
Yes.
Yeah, they're both 9s. So I'm allowed to add the exponent. I could say it's
9, 13, and 13?
Yeah. 5 plus 8. Since this is our notes, we want to be thorough, which is 9 to the 13th power. Am I going to calculate 9 to the 13th power and actually evaluate an answer? No. It's a huge number, right?
We just know it's going to be.
But we know that we could simplify this to 9 to the 13th. Okay? Let's do the same thing with symbols. Let's say I have n to the 10th power times n to the negative 4 power. Ooh, wait a minute. Can we do that?
Yeah.
Negative exponents exist, and we'll get into the details. But for right now, let's just work with one. What am I going to do with the 10 and the negative 4?
It's 10 minus 1. You can make it 10 minus 1.
I'm going to write it as this way. 10 plus negative 4, which is really 10 minus 4. And what's 10 plus negative 4?
6.
So it's, I'm sorry, n, not 10. Where did I get 10 from? N. N to the 6th. Okay. So that's the main rule, and we're just going to use it over and over again today. Any questions? Okay. So here's something new. Here's another concept that we're going to use a lot this year, next year, probably throughout your experience with math from now on. We're going to talk about monomials. Does anyone know what the prefix mono means? M-O-N-O? Yes.
1.
1. Means 1. So a monomial is a one of something. I'll explain what it is. Just trying to get this to. I used to be able to. I got a little bit of a.
To the power of 1?
No. I'll explain it right now. I'm just trying to get this to dry off so I can highlight this. Okay. Yeah, it's good. Mono means one. Ha! There we go. Smooth move, Mr. Contreras.
How do you spell that?
Monomials. Monomials. Okay, so a monomial is a single term in mathematics. So that means it could be a number. So negative 14. That's a monomial. Just the number negative 14. Positive 2. Just a single number. 1 billion is a monomial. It could be a variable. Let's see, x, because that's my favorite variable. It could be a combination or a product of numbers and variables. Notice I'm writing it plural. So here's one for you that's also a monomial. I could have negative 5 x squared y to the 4th power. Should I throw a z in?
Yeah.
Throw it in. Z. Product means what, guys? In math. Yes. Yeah. So it means to multiply. So it's a product. You're multiplying numbers with variables. So you could just have a single number and it's a monomial. You could have a single variable, it's a monomial. You could have two or more variables along with a number, as long as everything you're doing there is multiplying. It's a monomial. Okay? So we're going to be interested in these guys more often today. Okay? But what we're going to do is we're going to multiply them. We're going to multiply monomials, and we're going to use this rule that we just learned about to help us do that. Okay? So you guys ready? We got monomials, and we're going to multiply them. So we're going to find the product. Find the product. That means multiply it up. Okay. So let's start with just numbers. Those are monomials. We got 8 to the 7th times 8 to the 3rd times 8 squared. Bunch of 8s. And we want to simplify this down to some answer. So what do you think we need to do if we want 8?
8, 7 plus 3 plus 2.
Yeah.
And that should be the powers first, and then we solve it.
Since all we're doing is multiplying, we have the same base. You add the exponents. So that would be 12. 8 to the 12th. How much is 8 to the 12th? I have no idea. It's huge, but
We don't have to write it.
just leave it as 8 to the 12th. Okay? Any questions? Okay. Let's throw in some simple variables. for number 2. Ready? Let's do x to the 4th times x to the 0 times x to the 5th. Bunch of x's. But the important part is the base is all the same. Okay? So let's see what we're adding. This is x to the... Well, let's show the addition that we're going to do. We're adding 4. Huh?
Are we ever gonna do like multiplication and division on this?
Yeah. We'll get there. Well, technically we are. We're multiplying, but
Oh yeah.
but when we're multiplying powers with exponents, what do we do with the exponents? Add. So we got 4, we got 0. How about x by itself without the exponent?
That's x over 1, right?
X to the 1. So if you want, you can put a 1 there. Normally we don't put it. Plus 5.
X to 10.
X to the 10th. That's x to the 10th power. So I think, Zach, you were talking about maybe something like this. Let's do some proper monomials. This is kind of just getting us a little comfortable with this. But this next one is number 3. And let's say we have 3x squared. And we're going to multiply it by 5x to the 4th. So here's one monomial, 3x squared. We're going to multiply it with another monomial, 5x to the 4th. Okay. We got two things going on here. We got variables, right? And then we got the numbers multiplying the variables. Do you remember? We've called that number that multiplies a variable a name. It starts with a C.
A component?
Close. Coefficient. Remember we mentioned that before? This is called a coefficient, guys. I will keep on reminding you of that because it's going to come up a lot. So we got two coefficients, a 3 and a 5. Here's the quickest way to handle this. Take your coefficients, multiply those.
Yeah, can you just do it? Isn't that like a distributive property? Like you distribute them?
Well, sort of. The distributive property has to do when you're adding and subtracting terms inside the parentheses, but I know what you're meaning. Well, I'm showing you what your thought process should be. You take your coefficients, the 3 and the 5, you multiply those. You take your variables, your like variables, x's in this case, you multiply those. And then you get an answer. So let's see here. This is going to give us 15, right? And that's going to give us x to the 6th. 2 and 4 make 6, so 15 x to the 6th power. Okay? And we can go a little crazy with this. Negative 14x squared and 3x. Let's try that. Again, since this is the notes, I want to break this up and show the steps. Negative 14 times 3. X squared times x. And I'll write the answer underneath. Okay. So negative 14 times 3, that's
negative 42. So it's negative 42 x cubed.
x cubed. Why x cubed?
Because there's another x, and that can translate to the x to the first power.
Yeah. So really, we got 2 and 1 makes 3. So it's negative 42x cubed. That's not so bad, is it? Okay, you just got to be careful with what you got. Number 5. So let's do negative. I would do x's and y's. I'll stick with those. Negative 6x squared y to the 5th times negative 4x to the 3rd y to the 6th z cubed. Okay. So this time we have 3 different types of variables going on. We got x's, y's, and z's. Almost done. Okay. So let's see here. We got negative 6 and 4. Negative 6 times negative 4. I'll do the x's, x squared times x cubed. We got y's, y to the 5th times y to the 6th. And then we have z to the 3rd power. Nothing with z to the 3rd power, so. Let's see here.
So when we have two numbers with the same base but have different exponents, we just add the exponents, right?
Mm-hmm.
But when they have two different bases, then we just
They're separated. Like z didn't have any other z's to multiply with, so it's just going to be, our answer is going to have z cubed. Well, z to the 3rd, right? Z to the 3rd. I like the z cubed. Okay, so what do we got? 24? Yeah. X to the 5th power, y to the 11th power, z cubed. And that is our answer. So if you get a bunch of these today, you think you can handle that?
Yeah.
Easy peasy, right? Okay, so that's our assignment today on Delta Math. Multiplying some monomials, just like this. Any questions?
Nope.
Okay, so